Hello there. Welcome to the video lectures of engineering mechanics. So today we are discussing about the kinematics of rigid body. In the last video lectures we have seen what is a rigid body, and its application in engineering is very wide. And we are trying to find out different parameters, the kinematic parameters like velocity, acceleration and the displacement. Right? So when the body is going to be rotating about the one axis, and there we are finding the different parameters like angular displacement, angular velocity and angular acceleration. So there we can see in that connection the angular acceleration of a wheel is given by alpha is equal to, so here the alpha is equal to 18 minus t radians per second. So here is alpha is your angular acceleration and the t is going to be the time. So in this case our rotating object, that our rigid body is a wheel which is going to be rotating. If the angular velocity is 75 radians per second, suppose this is going to be angular velocity is equal to 75 radians per second at the end of 8 seconds. It means the t is equal to 8 seconds. The wheel have the angular velocity is 75 radians per second. Determine the angular velocity at the end of 10 seconds. So that means I need to find out the omega 2 suppose. And the t is equal to 10 seconds. Right? And how many revolutions take place in this 10 seconds? So I need to find out the n also. Within this 10 seconds, how many revolutions means the wheel has taken. So in this case, we can see there is a angular acceleration equations are available. Then how could you find out your omega 2, that means at 10 seconds and revolutions that wheel can make it. So in this case what will happen, we do have that equation that's going to be alpha is equal to 18 minus t. By using that part, we are going to be trying to solve this one. So now I am taking this alpha. Alpha is equal to 18 minus t. So as we know, this alpha I can define in terms of angular velocity as well as the time. So the alpha is nothing but the rate of change of angular displacement or angular velocity by time. So that d omega by dt I can take it. That is equal to 18 minus t. Once if I am going to get it, I am going to be taking the similar terminologies to the one side. So that I am going to be here omega is equal to 18 dt minus t dt I have taken. So once if I am going to be receiving this one, then I am going for the integration with respect to 0 to omega, and here 0 to t I am going to be taking. Once if I have this equation, so the integration of the integral 0 to omega, it is going to be the omega, that is equal to 18 dt integration, we are getting 18t minus t integration I am going to be getting t square by 2, right? And next plus c1 I am going to be getting. In this case, this is your angular velocity equation, because we need to find out the angular velocity at the time is equal to the 10 seconds, right? The given equation I have converted into the angular velocity. Now in this case the c1 is going to be unknown terminology. Then how would you find out this c1? So can you see here, this angular velocity is going to be 75 radians per second and the time is equal to 8 seconds are available. It means that if I am going to be taking the condition 1, so the condition 1 is going to be, I am substituting these two values in this equation. Now omega is equal to 75, that is equal to 18 into t is equal to how much here? That is 8 seconds minus, here is the t square is available, that's going to be 8 square by 2 plus c1. If I am going to be simplifying this equation, so then can you tell me what is the value of the c1? Once we are getting the c1, then I am going to be substituting in this equation. So then I can do the next step. So for me, the c1 I got it around minus 37. Right? I got it the minus 37. So I am going to be substituting in this equation. After substituting the condition 1, I got this equation. Once it is there, what I am going to do, I am applying the condition 2. What is the condition 2? We need to find out the angular velocity at 10 seconds. This is the angular velocity at 8 seconds. Right? Now, the t is equal to 10 seconds I can apply here. In condition 2. So that omega is equal to 18 into 10 minus 10 to the power of 2. So 10 to the power of 2 by 2 minus 37. So if I am going to be simplifying this equation, what I will receive from here? So what is the value of the omega 2 I am going to be say here? Omega 2 means at the 10 seconds. So I got it around 93 radians per second. Can you see? Omega 2 is equal to, I got it 93 radians per second. Omega 1 is equal to 75 radians. Now, what else we need to be calculate from this one? We need to find out the number of revolutions in 10 seconds that I want to calculate. So, what I am going to do, by using this equation, as we know, the omega is nothing but I am going to be getting d theta by dt, suppose. If I am going to be simplifying this equation, the theta is equal to omega t, I will get it. So that means I want to do the integration of this omega so that I can get it this part. So now I am writing here, this is going to be angular rate of change of angular displacement by time, that is equal to 18t minus t square by 2 minus 37. So then what I am going to do, I am going to be taking the similar terminologies. That is going to be d theta is equal to 18t dt minus t square by 2 dt minus 37. Right? If I am going to be integrating 0 to t or 0 to theta, and here is the 0 to t. So I am going to be getting from this equation, that's going to be theta is equal to, this is going to be 18 t square by 2 minus t cube by 6 minus 37t plus c2, I will get it. So can you see in this equation? So in this equation I can get the angular displacement. So once if I am going to be getting the angular displacement, so then I am going to be trying to calculate the n. So as we know that the theta n is equal to, so omega is equal to 2 pi n by 60 we do have. So this is going to be your angular displacement. So this angular displacement I am going to be writing in terms of the theta. So then the 2 pi n I am going to be getting over here. So right. So then n is equal to theta by 2 pi. If I am going to be substituting this equation so that I can calculate the number of revolutions. Yeah. After getting this angular displacement, if I am able to calculate the C2. So for this C2, we are taking the two conditions when the t is equal to 0, when t is equal to the 10 seconds, right? So in this case, we are going to be getting over here, that is going to be your theta naught, and here you will get the theta. So if I am going to be substituting in this equation, then I can calculate the theta value here. As we know, when the time is equal to 0, the theta naught initial displacement, angular displacement is the 0. After certain time, the 10 seconds, it will cover certain distance, right? So on this basis, I am going to be substituting here. If I am going to be substituting t is equal to 0, then it is going to be the t naught equal to, then the total length. It means that the C2 is equal to theta naught, I will get it. Because I am substituting t is equal to 0. These three parameters will goes to the 0, and then C2 is equal to, here is the theta naught. So I am going to be substituting another equation, that's going to be t is equal to 10 seconds. So then here 10, 10, 10. I will get the C2 also. So I am going to be substituting in one terminology and then I can get it. We do have another equation is this part. By using this equation, we can get the revolution. Or we can take it the omega is equal to, already it is available, the 10 seconds is equal to 93 radians per second. So n is equal to omega by 2 pi, I can take it. So omega is equal to here 93, 2 into pi. So I am going to be getting here, that is in the RPM I will get it. Because we are not dividing with the 60. So automatically the values, whatever the revolutions we are getting, that is in the RPM. So what is the final answer from that part? Yeah, from this one I got it around the 14.8 RPM I got it. So this way we are going to be calculating the revolutions of that wheel. So thank you. I hope you are able to understand this concept, how to solve this one. Either by using this method, by using the integration, by calculating the angular displacement, and then we can substitute in this equation. Or you do have omega at the 10 seconds is available. Then I have a formula omega is equal to 2 pi n. Then I can calculate the n is equal to, this is the in RPM. So still you feel any difficulty, please put in the comment section so that I can reach you. So all the best.